Do you want to really understand how Lambdas scale in AWS? In this video, we're going to be diving deep into the process of scaling with Lambda. Hi guys, my name is Sam with Complete Coding, where our aim is to make you into the best developer that you can be. In this video, we're going to be looking at the processes of scaling your AWS Lambdas, how it works, and some things that you need to watch out for when you're setting this up. So to start with, we need to work out how Lambdas scale. So when you get a request, then what happens is there is a cold start. If you want to find out a lot more about cold starts, I'll link a video up here, but I'll give a quick overview. A cold start is where the AWS system needs to download all of the code for your Lambda, set up the environment, and create a container for your Lambda. Inside that container, it can then run your code. It keeps it alive for a little while so that the next time it comes along, that container can be reused and you don't have to download the data every single time. So in our example, we're going to get hit with a Lambda request once. It's going to perform the action and then it's going to wait. It's then going to get hit with a second request and it's going to function, and then it is going to wait again. This will happen as long as every time you make a request, the function is in a wait state. Well, what happens when you get some more traffic to your endpoint and you get one request come in, and whilst that one request is functioning, you get a second request. In this case, what happens is AWS creates you a second container. For this container, there is a new cold start. So it downloads all the code, creates a new container, and runs the second request in parallel with the first. And that is how you get concurrent Lambdas running. Now that you've got two containers running, they're both waiting, and they'll both wait for about 10 minutes before shutting down. If you then get another request, it will go to the first container, and that will run and reset that wait timer. So if you continuously get just one more request every now and again, that first container will repeatedly reset its wait, whilst the second timer will eventually reach its timeout and then will cool down. This means you're back to your original state, so if you get another two requests that come in at the same time, you have to make that second container again, which will have a new cold start. This is really the process of scaling. As you get more concurrent requests, so say you have 5 different Lambda containers running, and all of a sudden you get 10 requests all at the same time, the first 5 will go to the existing 5 containers, and the next 5 will create 5 new containers. This is really cool as it allows you to scale up almost indefinitely with the requests that come through to your APIs. So whilst that is the process for how your Lambdas scale, there are some things to think about. By default on AWS, every region that you have has a limit for the number of concurrent Lambdas that can be running at one point. By default, this is 1,000. So it means you have 1,000 available slots for Lambdas to be running. If you have 3 separate Lambda functions and you have one Lambda function that is running 100 at a time, another one that's running 50 at a time, and say a third one that's running 200 at a time, everything will work perfectly. The issues arise when you have a lot of concurrent Lambdas running at the same time. say you have 500 Lambdas for the first one running at the same time, and then Lambda 2 has, say, 400. That means you've got 900 Lambdas running at the same time. So when the third Lambda tries to run another 100, it's going to get to the 1,000 limit. But if it tries to run 200 at the same time, then you're going to hit throttling. Throttling is where AWS says you're using all of your concurrent Lambdas, so we're going to reject this request with a 429 response. This can be really frustrating as it's really hard to debug, and it means that certain endpoints or certain Lambdas that you want to run just won't run. So to resolve this issue, there is a thing called reserved capacity. So in your Lambda, you can say, I'm going to reserve a certain number of my Lambda executions specifically for this one Lambda. So if we had those 3 Lambdas again, you could say that Lambda 1, I want to reserve 300 spots, Lambda 2, I want to reserve 200, and say Lambda 3, I want to also reserve 200. That means that you have 300 for one, 200 for the other two, which is 700 of your 1,000 available Lambda concurrencies reserved. You can reserve up to 90% of your Lambda concurrency, and this is put in so that you don't reserve everything, because if everything is reserved, then any Lambdas that you add in won't have any capacity to run. The disadvantage to these reserved capacities is the fact that you can never scale above those. So, for example, if your usage changes and Lambda 3 starts getting hit a lot more, it will go up to its 200 capacity, but it will never go past 200. You still have those extra 300 Lambda concurrent resources available, but because of the reserve capacity, you'll use up to your reserve capacity, but never any more. This is just something to think about, and as your company scales, you may need to change the volume of your reserve capacity and check and monitor using something like CloudWatch to see if you are ever hitting those limitations and the throttling imposed by them. One quick note is this 1,000 limit is a soft limit. If you find yourself actually hitting the limit of Lambda concurrency, then you can actually do a service request to AWS, who can increase that limit from 1,000 up to a suitable amount for your use case. If you aren't actually using that much and you just ask for a request, they might just say no and say that you need to allocate your reserve capacities more effectively. In this video, we have looked at Lambda scaling and reserved capacity. It's a really interesting topic that can generally affect the way that your Lambdas function, and is something that as your company or as your app scales, you might need to think about. So if you've learned something new in this video, it would be really cool if you'd hit that like button, as it helps share this video to more developers just like yourselves. And if you haven't done already, make sure to subscribe down here, as then you can get notified next time I upload one of these deep dive AWS videos.